Okay, we're on mixed exercise 7 from the first year core textbook, and we're looking at some proofs. So question 16, so this is not too bad because we're actually told how to tackle it. So we're told to complete the square. And actually this sort of type of proof does come up a lot in various forms. So sometimes you're asked to show that well, as we are in this case, that something is always positive or quadratic is always greater than 0. Sometimes it comes up in sort of calculus, and you're asked to show that something never has a negative gradient. But this idea of showing that a quadratic is always positive or always negative, because it would be the same method, does come up a lot. Right, so this is the quadratic. So they've told me to complete the square, so I might as well crack on with that. So that would be n minus 4 all squared minus 16 plus 20. So that would be n minus. So, even if I wasn't sure about the proof, I'm going to be able to get some marks for that. Okay, and they're asking me to show that that is always positive. So basically, I'm trying to show that that is always greater than 0. So the best way is just to say, well, n minus 4 all squared. So the minus 4 is kind of irrelevant there. It's anything squared is always going to be greater than or equal to 0. This is a proof, so you do need to be really careful that everything is totally accurate. So if I'd have just put greater than 0 there, that would not technically be correct, because it could equal 0. If n equals 4, then that does equal 0. So anything squared is always greater than or equal to 0. So if you then add 4 to it, it's always going to be greater than 0. So this would be correct. I wouldn't write it for this particular proof, but that would be a correct statement. So n minus 4 squared, so moving from this to this, if anything squared is always greater than or equal to 0, if you then add 4 to it, it's always greater than or equal to 4. So that is correct, but that's not really answering the proof they asked for. So that's what they asked, to show that it's always positive. Okay, job done. Right, let's just check that we didn't have anything extra in their solution. Yeah, so they've said the equivalent, but said it in words. I mean, you could also refer to the vertex and back it up with a sketch of the quadratic. So obviously, in completed square form, you know that the vertex of this quadratic would be at 4, 4. So we could even just do a quick sketch of the quadratic. So that's at 4, 4. That's at 20. Because I've got the intercept there, but this would be absolutely fine what we wrote there.